So, Phillipa, you're doing your PhD here at the Open University in the Science Faculty. Can you tell me a little bit about your background and how you got to where you are now?
Sure. So I've got my BSc in astrophysics, and I've always been interested in science and particularly space, really interested in the big pictures, where do we come from, the universe, that sort of thing. So coming to the Open University was a way to pursue that, but I wanted to get into the actual space missions rather than traditional astrophysics. So the research facility here, the Centre for Electronic Imaging, offers an opportunity for PhD training in imaging systems for space missions. We have a very close collaboration with ETV Technologies, which provide the sensors for some of the really big missions. For example, the Hubble Space Telescope contain those same detectors.
So ETV, that's a kind of external industry that the Open University is in partnership with.
Yeah, having the technology, the ETV technology collaboration means that we have the detectors from ETV to test as an in-house kindness. It means that we can research them to great detail and feed back any advice that we have on how they can improve them, and as well as that we can speak to the people that design them and the experts they have there for any ideas that we have for our research.
Okay, you've talked about missions and detectors,
Yep.
so presumably as a result of doing your PhD, do you have a detector going up on a mission? Can you tell us about it?
I do. So this is the detector I've been working on here. It's a little like the sensor that you might find in a camera or in your mobile phone, but instead of being optical, it's actually for X-ray.
Okay.
And this will produce graphs, such as that you can see here. And the idea is that while it's up, it's an Indian mission that's going to the moon, and it's going to be looking at the elemental surface, so what the moon's surface is actually made of.
Okay. I thought we already knew that though from moon rocks.
Well, we do have some moon rocks from, for example, the Apollo missions. They brought a lot of samples back. However, they were only in a very small region of the moon's surface. And other mapping missions have indicated that there are different rocks and different ages over the surface of the moon. So by doing this orbital mapping of the whole surface, we can understand whether there'll be different compositions in different areas.
Ah, so are we expecting to find, for your detector to reveal different elemental compositions in different ages of rocks on the moon?
That's possible. That's something that we're very interested in.
Is it going to help with anything to do with detecting life in the universe or anything like that? That's the question we always left, the unanswered question that we're ever in pursuit of.
That would be amazing. I'm not sure for life as such, but certainly some of the recent research in this department has revealed that there are some water traces on the moon. So it's possible that this detector may, if not find water as such, might find traces, and this might give an indication as to where it might be interesting to send future missions for samples or manned missions to investigate further.
So is this the actual one that's going on the spaceship?
This is just a sample that I've been working on.
Right.
However, the main detectors will look like this.
Okay.
So it's an array of the same detector, which gives us a much larger area, and there'll be several of these together, and this will help to give us a much stronger signal while we're up there, so we can look at a much larger area.
So when is the Indian mission going to go to the moon, and when will you start getting data back?
It's looking to launch about 2017, and the launch time's quite short because it's only to the moon, so around 14 days. So as soon as we get there, we should start to get the data back.
So being part of an Indian mission, have you got to visit India and meet the team, be on the ground as it were?
Yes, a couple of years ago I went over to India for a couple of weeks, and I was working on some of their test systems, how to improve, and meeting all the people that were working on the mission, which was really great to share some ideas. I also did some testing over there with their equipment and compared it against the results I was getting in the lab there, just to check for compatibility, and that all looked really great.
So that was a sort of an invitation on a kind of consultancy basis?
Yeah, absolutely. Yeah, they were very happy to have us there, and I think we really helped them a lot with their test setter.
Now, there's always a lot of talk about encouraging women into STEM careers, science, technology, engineering and maths, and you are in one of those STEM careers. How have you found it, and would you recommend it perhaps to other women who are starting out on a scientific career?
I've always been very interested in science and maths, so I think I just pursued that as an interest really, and there are less women than men at the moment, but that hasn't put me off because I really enjoy it, and I think that's what's important. If you enjoy it and you want to go for it, then I think just kind of follow your dream. It shouldn't hold you back.
So what are your hopes and ambitions for the future then?
I want to stay in space science and hopefully get involved in some of the big missions in the future.
Well, I wish you the best of luck. Just one last
Thank you very
question. You studied your BSc at a conventional university and then you came to the Open University.
Yep.
Has it been a different study experience?
It's been very different, but I think it's been a lot better, to be honest, for a PhD study, because it's more like a research facility than a university. So everybody here tends to work more office hours, and you treat it more like a job really than kind of a studying university. Everyone's very dedicated to their work and really interested in the research that they do.
So less of a student, more of a kind of grown-up world.
Absolutely, yeah.
All the very best for the future.
Thank you very much.